In section 2.2, we're going to take a look at solving some linear equations in one variable. And a linear equation is of the form ax plus b is equal to 0, where a and b are real numbers and a does not equal 0. So we have a few different types of equations, and hopefully we'll get to one of each at least. And a conditional equation results in a finite or a countable number of solutions. And then an identity results in an infinite number of solutions. But then an inconsistent equation has no solution at all. So this first example, 3x plus 2 minus 2 times the quantity x minus 1 is equal to 3 times the quantity 2x plus 3. And we want to solve this equation for x. So the first thing that we want to do is to simplify each side of the equation. And so anything, the order of operations, please excuse my dear Aunt Sally or PEMDAS, that applies for simplifying one side at a time. So parentheses and exponents, multiplication and division. So right now we're going to multiply by distributing this negative 2 to each of the terms inside the parentheses. So minus 2x and then a plus 2. And then the same thing on the right. Multiply 3 times 2x, which is 6x, and then 3 times 3, which is 9. And on the left, we still have to combine like terms. So we're going to add or subtract. And so we have 3x minus 2x, which is just x, and 2 plus 2, which is 4, is equal to 6x plus 9. At this point, we need to move the x's together to the same side and the constants together to the opposite side. And it doesn't really matter which one you move first as long as you're using the inverse operation to move it over to the other side. So the first one, I'm going to move the x. And to do that, because it's a positive x, I'm going to subtract x from each side. And we now have 4 is equal to 6x minus x, which is 5x plus 9. At this point, this is a more familiar type of equation. It's just a two-step from here on out. And the next thing I would do to isolate 5x is to move the plus 9. And I would use the inverse operation of subtraction. And remember, whatever you do to one side in an equation has to be done to the other as well. And we have negative 5 is equal to 5x. And then lastly, divide both sides by 5. And we get x equals negative 1. Okay, so that means that this is a conditional equation because it resulted in a finite number of solutions. There's only one solution to this equation, but we want to check ourselves. So we're going to do a quick check to ensure that our answer is correct. And to do our check, we're going to substitute into the original equation. So go back to the initial equation, substitute negative 1 anytime there is an x. So 3 times negative 1 plus 2 minus 2 times negative 1 minus 1. And our goal is to see whether this is equal to 3 times 2 times negative 1 plus 3. That would be the right-hand side of the equation. Okay, so evaluate each of those. So 3 times negative 1 is negative 3. Negative 3 plus 2 minus 2 times negative 1 minus 1, which is negative 2. Okay, and that's negative 3 plus 2, and then plus 4, because negative 2 times negative 2 is positive 4. And then on the right-hand side, if we simplify this sum, 3 times 2 times negative 1 is negative 2 plus 3, and negative 2 plus 3 is 1, so 3 times 1 is also 3. So we get 3 on the left and 3 on the right, and therefore we can say that negative 1 satisfies this equation, and therefore negative 1 is the solution to the equation. Let's take a look at another example. 5 minus 2 times the quantity 3 minus x is equal to 2x minus 1, and our goal is to solve for x. Okay, so the first thing that we'll do is distribute, and we have 5 minus 6, and then negative 2 times negative x is plus 2x, and that is equal to 2x minus 1. Next thing is to combine like terms. Okay, so in this case, 5 minus 6, those are like terms, and when we subtract them, 5 minus 6 is negative 1, and we are left with negative 1 plus 2x is equal to 2x minus 1. Hey, at this point, you probably kind of notice how similar both sides look. We can use the commutative property and rearrange the left-hand side to equal 2x minus 1. And once you realize you have exactly the same thing on both sides of the equation, you can stop and you say that this is actually an identity. And what that tells me is I can plug any value of x into the equation, and it would satisfy both sides. Okay, and therefore the solution is all real numbers. Okay, and the real number system is often abbreviated as this capital R with an extra bar. Okay, another example. Let's solve this equation. Negative 4 times the quantity 8x plus 3 minus 16 times the quantity negative 2x minus 1 is equal to 10. Okay, and so we'll distribute, and we get negative 32x minus 12, and then we'll distribute again with the negative 16, so that's positive 32x plus 16 is equal to 10. Okay, the next step is to combine like terms. The negative 32x plus 32x is 0x, or just 0, and we're left with negative 12 plus 16, which is 4. And bring down the 10. So 4 equals 10. Right now we have reached a contradiction. 4 obviously does not equal 10. So if that happens, you get something that really is not equal, then we're going to say there's no solution to the equation, that this equation is inconsistent. And this last example, it definitely does not look like the other equations. In fact, initially it's a rational equation, and we involve some fractions in our equation. So one option is just to try to get rid of the fractions altogether, and one way to do that is to multiply both sides by the LCD, or the least common multiple of the denominators. And that would happen to be just whatever this denominator is, because it's common to both of those fractions. So x minus 2. And then once we multiply both sides by x minus 2, we're just going to try to simplify and see what we find. Okay, so x minus 2 gets multiplied to this first term, and then it also gets multiplied to the 4, and then also on the right, x minus 2 gets multiplied to that fraction. Okay, so we're left with 8x plus 1 plus 4 times x minus 2 is equal to, okay, again, the x minus 2's would cancel, so we're left with 7x plus 3. At this point, it's a linear equation, and we'll just solve using the techniques that we learned previously. Okay, so we have 8x plus 1, distribute the 4, So plus 4x minus 8 is equal to 7x plus 3. Combine like terms on the left. Okay, so we have 8x plus 4x, okay, which is 12x, and then 1 minus 8, or negative 7, is equal to 7x plus 3. We want to get the x's to one side and the constants to the other. And so when I typically decide what to move first, I choose the smaller x. So I'm going to move the 7x. Okay, that gives us 5x minus 7 is equal to 3. Add 7 to both sides. So we're left with 5x equals 10. And then the last thing is to divide both sides by 5. And we get x equals 2. So just as it is important to check your answers with all equations, it's doubly important to check them with rational equations, because your solution could be extraneous, meaning it works for another form of the equation, but it doesn't work for the initial or given equation. So let's take a look at this one. We said the answer is x equals 2. But look what happens if you plug 2 into the initial equation. If I plug 2 for x, I get 0 in the denominator, and that is undefined. So 2 actually does not work. It does not satisfy the original equation, and therefore we're going to have to just say that there is no solution.